Hey everybody! In this video we're going to talk about solving a 3x3 system of linear equations. For these equations, the first step is going to be to eliminate a variable twice, or to see if you can get two equations with two of the same variables in it. Let's go ahead and take a look at what I mean. Again, I'm going to label each of my equations here, equation 1, 2, and 3. And I'm going to take equation 1 and I'm going to add equation 2. So that's x plus y minus 2z equals 4, plus I am actually going to add equation 3. I apologize. Which is 2x plus y plus 2z equals 0. So when I add these together, I get x plus 2x is 3x. Remember, we can't add things together or combine them unless they're like terms. Y plus y is 2y. Negative 2z plus 2z is 0. So that eliminates that variable, and then 4 plus 0 is 4. This equation I'm going to call equation 4. Now, I'm going to go ahead and I'm going to take equation 2. And then I'm going to take 2 times equation 3. So I'm using two different equations here. X minus 3y minus 4z equals negative 2. And then 2 times equation 3 is 4x plus 2y plus 4z equals 0. So when I add these equations together, I get 5x minus y. The z's also go to 0 again, and it equals negative 2. So now I have what I wanted, which was two equations with two of the same variables, because I got rid of z twice. Now, if I were to take 2 times equation 5, that would be 10x minus 2y equals negative 4. Now, why did I do that? Because in equation 4, I have a positive 2y. So when I add these together, I saw I was going to get a 0 here. But I also have a 3x plus 2y equals 4. So I end up getting 13x equals 0, which after I divide by 13, I'll get x equals 0. So that's my solution for what x is. Now, with a 3x3 system of equations, what my goal is to find the point x, y, z, where all of these lines, yes, they're lines, but in three-dimensional space, the point x, y, z where all of these lines intersect. Okay, so now I have x. What do? I can plug x into either equation 4 or 5, and I can find y. Let's go ahead and plug it into equation 5. So I get 5 times 0 minus y equals negative 2, or this is going to go to 0, so I get negative y equals negative 2. Now, if negative y equals negative 2, what does y equal? Y equals a positive 2. So now I have a solution for x and I have a solution for y. What do? I plug both of those, x and y, back into one of these equations. Let's go ahead and plug it into equation 1. So x is 0, and then I'm going to add y, which is 2, minus 2 times z, which is 4. So I'm going to get 2 minus 2z equals 4. Subtract 2 on both sides. I'm going to go ahead and erase this to give me some more space. I get negative 2z equals 2, divide by negative 2, and I get z equals negative 1. So even though I have x, y, z here, I want to write it as a point because that's my solution, which is going to be at 0, 2, and negative 1. So there's my first example for solving these equations. Now let's go ahead and look at this next one. Let's label our equations 1, 2, and 3. Now what I notice as I look at this is I notice that 3 already has the x eliminated. So if I can eliminate x again, then I would have 2 equations with 2 of the same variables. So let's go ahead and take equation 1, which is 2x plus y minus 2z equals negative 7. And let's add negative 2 times equation 2. Now why did I do that? Because I will get a negative 2x, and that's going to make x eliminate, which is what I wanted. Minus 2y minus 2z equals a positive 2. So when I add these together, my x's cancel, which is what I wanted. Then I get y plus negative 2y, which is negative y. Then negative 2z plus negative 2z is negative 4z. Doesn't look like a 4. And then negative 7 plus 2 is negative 5. So let's go ahead and label this equation 4. And now equation 3 and 4 have x and z, or y and z in them. So can I eliminate another variable? If I take 2 times equation 4, that's going to be negative 2y minus 8z equals negative 10. My equation 3 is negative 2y minus z equals negative 3. That doesn't quite eliminate anything. So what I need to do is multiply the 4 by negative 2. So I'll get positive 2y plus 8z equals a positive 10. And then when I add these together, my y's will go away, and I get 7z equals 7. So z equals 1. Now to continue to solve, I'll plug z back into 3 or 4. Let's plug it back into 3. So negative 2y minus z, which is 1, equals negative 3. And then after some solving, I'll get y equals 1 as well. Now what do I do with this z equals 1 and this y equals 1? I plug both of those into something with x. Let's plug it into equation 2. So I get x plus y, which is 1, plus z, which is 1, equals negative 1. So I'll get x plus 2 equals negative 1, or x equals negative 3. So what is my solution here? It's x, y, z, or negative 3, 1, and 1. So that is my solution to this equation. And there's 2 examples of solving a 3 by 3 system of linear equations.